We are going to go through chapters 9 and 10 together because they cover reliability and validity, and really they're related but different. So that's why I wanted to include the two together. So when we're looking at validity, we're looking at the extent that the measure is used that is true to its intended purposes. So are you measuring what you want to measure? So the goal of validity is being as accurate as possible. So when we look at reliability, we're looking at consistency, making sure that if we do the same test over and over, that it's repeatable, that you get the same types of results, that you can reproduce the same type of study, and that it's consistent and stable. So when we're looking at those two things, they're very often confused. So let's look at those side by side. So when we're looking at reliability, it's when we're looking at the outcomes are consistent, when the experiment is repeated over more than once. And when we're looking at validity, we're looking at that it's testing actually what it's supposed to test. So let's dive into measurement, and we'll get into this a little further as well. So when we're looking at measurement, we want to look at measurements that are both reliable and valid. So when we're looking overall at measurement, that's kind of an assignment of a number to an object or events according to certain rules. So when we're looking at measurement itself, we're looking at that quantifiable component that is allows us to really dive into analyzing things using statistics. So numbers are usually more defined and clearer to communicate, so that's a common use of measurement is those numbers, and it relates to objectivity and efficiency. And when we're looking at the different levels of measurement, and this is important, you want to look at nominal. It's just kind of a label. And categorical, it identifies a particular group. When we're looking at ordinal, we're looking, again, like the word infers, we're looking at an order. An interval is also in order, but it's an estimation of the distance between the scores. So we're looking at how far it is between the scores. And then when we're looking at ratio, it's defined by distance, order, and 0 point. So when we're looking at measurement error, this is really important to examine as well. Why things are inconsistent or inaccurate. And it may have to do with who's doing the testing. And if there's variability between different raters or the way things are coded as well. So when we're specifically looking at test and retest reliability, and that's what we're looking at, reliability, whether we can replicate a test and get the same results. So we're looking at two testing times that may be compared statistically, may be a way to do that, or it may be by administering the same test to the same people and seeing if you're getting the same results. So in addition, when we look at statistics, we want to look at the type of statistics that test things specifically. So we need to know what statistical tests are appropriate for certain uses. So that's where we're looking at Pearson and intra-class correlations. So when we're looking at things that are alike, we want to look at Cronbach's alpha. And again, you don't have to memorize all this, but just know that there's different statistical tests that do different things. And it's important to know that when you are reading the studies, to make sure that the right statistics are used for the right purposes. So kind of keep that in mind. So kind of rules of thumb An alpha of 0.70 is acceptable for new measures. An alpha of 0.80 is for established measures, and we're looking at reliability when we have an alpha that's higher of 0.9 or higher. So that's really desirable when we're looking at clinical evaluation. So when we're looking at those measures, we want to look at where those errors can occur. And again, this is really important when you're reading the different research articles, and we want to look for systematic errors, a consistent error that occurs, or if there's a random error, that they're inconsistent or unpredictable errors. And then there's random errors that can cancel each other out. So really looking at why there may be errors is really important, whether it was structured inappropriate, that it's a systematic error, or if it's something that really occurred kind of randomly, those types of things. So you want to look at not only the numbers, but do those numbers make sense, and is there some outlying factor that impacts the reliability of those measures. So when we're improving reliability, we want to make sure that we have really good raters, that they're trained well, and that there's some kind of quality control with the raters, assuring that they're consistently rating the same way. Calibrate instruments, and that's as simple as calibrating scales in practice, making sure that that scale is is reliable as far as measuring the same weight, the same time. That's why it's so important to have folks weigh on the same scale all the time, because that incorporates that reliability that a different scale may measure a little different. So just take a look at all those components that really involve reliability, so you're keyed into those factors when you're doing your critical analysis. So when we're looking at the two together, here we're bringing things together a little bit. We're looking at validity and reliability. Looking at, as we spoke about, was the consistency and the test-retest components. And then as we dive into validity, we're going to look at whether an instrument tests what it's supposed to test. So there's different types of validity. So we're going to dive into that. So when we're looking at content validity, we're looking to the degree to which a measure includes all the dimensions of the phenomena, and it doesn't include other things. So really focus on the content. When we're looking at criterion, we're looking at the ability of the measure to predict an outcome. So we're really looking at very specific information when we're looking at criterion validity. And when we're looking at construct validity, we're looking at how a measure relates to other measures of the phenomena. So we're looking at how it's evaluated. So it may be evaluated by correlation with other measures in the same phenomenon. So when we're looking at both reliability and validity, another level is bringing into sensitivity and specificity, So sensitivity is the proportion of positive results obtained on a measure under the evaluation. So sensitivity focuses on that you're getting those positive results when there is a positive diagnosis or experience. And specificity is the proportion of the negative results obtained on the measure under evaluation. So let's dive into that, because that seems a little sometimes confusing. So when we're looking at, let's change the words a little bit to precise and not accurate, or precise but accurate, those types of things. When looking at the context of reliability and validity. So what we want overall in the test that we're doing, say a screening test or a specific test for a diagnosis, we want to make sure that it is reliable, valid. It is also precise and accurate, meaning it's specific, and sensitive, meaning it truly tests what it's supposed to test, the positivity of a disease being there, and also it shows if a disease is not there. So this is a real critical factor when we're looking at diagnosing, is not only looking at reliability, that it's consistent, but also consistent for what it is testing. But we also want to make sure that it proves that something may be a negative diagnosis, and it would prove a positive diagnosis as well. That's when we dive into specificity and the specific nature of a particular test. So think in terms of maybe a pregnancy test. We want to make sure that it's consistently measuring pregnancy, that it also will give us a negative when it is negative and a positive when it's positive. So let me know if you have any questions about these concepts.